Hi students, welcome to this course, PLC Automation, an introduction to programmable logic controller. I am Professor Yao. Dual time off, delay off. The keywords: a building, an exit door light, the parking lot lights, the door lights. When the lights are turned off in a building, an exit door light is to remain on for an additional 45 seconds. The parking lot lights are to remain on for an additional 3 minutes after the door lights goes out. The three outputs are identified in figure. For more delay of outputs, an additional repeated 2 lines of logic are added as required. This is the PLC timer program for parking lot. And this is a timing diagram for this example. A timed interval example. The keywords: a timed interval, a specified time, a vacuum pump, embedded interval timing. The timed interval starts a specified time after a process is turned on and continues for a specified time. An example would be process where a vacuum pump is required to be on for an interval during the process. Figure 9.13 shows a program where the vacuum pump control relay 20 goes on after 8.7 seconds and runs for 7.3 seconds. That means that during the interval 16 to 8.7 seconds. The overall system's control relay 17 continues to run after the time interval is completed. This picture shows the time interval programming PLC program, the timing diagram. Industrial process timing application. The keywords: a surface hardening, the metallurgical, a solenoid valve, quenching, overheating or even melting, a mechanical layout. The manual, low limit switch, upper limit switch, the heat generator, manual control, a safety shield. The station carries out a surface hardening process on a steel ring. Hardening is accomplished by heating the steel ring to a high temperature and then immediately quenching it cooling it very rapidly, the metallurgical result is a relatively hard surface on the steel ring. The heating is done by a non-contact induction heating process. A high current in the circular coil around the outside of the part produces high circulating currents in the part. The part therefore heats up very rapidly. The coil has cooling water circulated through its outer half to keep the heating ring from overheating or melting. The quench is then done by spraying cold water on the part. The quench water is pumped into the inner half of the induction coil. Spraying the part with cold water through the main holes in the inside of the coil results in fast cooling, which produces a case-hardened surface. A mechanical layout of process station is shown in figure 9.14. The process sequence of this operation is as follows. The master push button is depressed, turning the system on. The part is pressed on the mandrel. Both left and right start-up buttons are depressed. At this point, or any other time, pushing any stop button stops all processing action. The part is raised from bottom to top by pneumatic air action. A solenoid valve supplies this air to pneumatic elevating cylinder. The lower limit switch must be actuated before the part will rise. Low limit switch actuation indicates that there is a part on the mandrel and that the mandrel is down. Note that the limit switch opens as the part leaves the bottom position. The mandrel makes the contact with the limit switch at the top of the travel. It comes on for 10 seconds and goes off. Quench comes on for 8 seconds and goes off. The part returns down by gravity and spring action. The upper limit switch becomes inactivated when the mandrel starts down. The part and mandrel reach the bottom. The down limit switch is again actuated. The system should reset. The part is removed. Some optional features, some optional features not included in this program are: if you assume the heating generator and both water pumps are on, interlock would be added to ensure they are running through the process. The same ring part could be processed 2 or more times. We could require the ring to be removed after step 12 before resetting takes place. Is proper temperature reached? A thermocouple sensor could be incorporated to monitor temperature. Manual controls for setup could be added. These are up, heat, and quench. Safety features could be added, such as a safety shield that lowers during heat. Where does the process restart after interrupted power is restored? Other features as required. The next step is to assign PLC register or address numbers to the various input and output. Here's the input and output I/O assignment. A ladder diagram to carry out the process is then developed, as shown in figure 9.15. The next step is draw the connection diagram for the PLC. There are 8 input connections and 5 output connections, 3 to process actuators, and 2 to pilot lights. The connections diagram is illustrated in figure 9.17 and 16. The final 2 developmental steps are to program the PLC for the process, and make modifications are required. This picture shows the layout of heating quench station layout. This picture shows the PLC program for the heat quench machine operation. This picture shows the connection diagram homework. Handwriting of keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.